drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. Oh, wow, watch this. I have a good picture there. I've got,
Beautiful picture, Dave.
well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
How about
Which proves that Mr. Galileo was correct in his findings.
Okay, so that was the video that it's in our notes. Yes, I know to us, we know that even though we've never been on the moon, that there is no air on the moon. But it makes a huge difference when it comes to physics, okay? It makes a big difference when we're talking about what's going to happen. It makes a difference on how things are going to react regarding motion and movement. So it says here, though, what happens when a hammer and a feather are dropped from the same height in a vacuum? What would it be another vacuum that you just saw? The moon. So I'm going to put right here, example, moon. So watching that video, they hit the ground at the same time. Now, the next part here, though, is, well, why? Why does this happen? Well, this happens here because, wrong pen. I'll use this one. Because there is no air resistance to slow down the feather. It says here, though, but is there gravity on the moon? Again, I'm pretty sure I'm going to just, take a stab at it. I'm pretty sure you've probably never been to the moon. I've never been to the moon. But is there gravity on the moon? Okay. So that's the next part here that they're asking. Well, yeah, there's gravity on the moon. How do you know? How do you know if you've never been to the moon that there's gravity on the moon? You know that there's gravity on the moon because you just saw it in that video. Because things, for an example, the feather as well as the hammer, fall down on the moon. Is the gravity on the moon the same as the gravity on Earth? Well, no, it's not. How do I know, though? How do I know if there's... First thing, how do I know that there's gravity on the moon? Because, for an example, I saw the feather and hammer fall. But how do I know that it's not the same? Because objects on moon do not fall the same speed as Earth. Go back to that video again. Did that hammer or moon fall just as fast as it would have on Earth? I don't know, Miss Munson. That was a video. It was kind of hard to tell. I get you. Now let's go back to, yes, I understand there's movies that we watch and we've seen it. Those movies are probably not real. They were made somewheres. But if we have to go back and pull the information that we've seen in the past with astronauts on the moon, how do they walk? If they were to hop or jump or walk, don't they kind of like walk and hop and jump slowly? It's not like they walk and jump over here. If they were to fall, they were to fall a lot like easier, right? And why do they fall easier or slower? Because the gravity on Earth is greater than the gravity on the moon. And because of that, it says here that the moon's gravity is 1/6 of the Earth's gravity. What does that mean? It means that the moon is 6 times smaller than the Earth. What if the moon was 6 times larger? Well, then that means that things would fall faster on the moon and it would fall 6 times faster. It would feel 6 times heavier. Now, it says here though, free fall. All objects have the same constant velocity when falling, which is what we call free fall, or we call this gravity, which is always negative 9.81 meters per second square on Earth. This number is on your formula chart, but again, it's a number that you're going to memorize because you're going to use it so much this whole school year. Now, why is that negative there? Remember, in physics, we can have a 0 as a valid answer. We can also have negatives as valid answers. Negatives in physics don't mean that you owe money, okay? Negatives in physics talk about direction. So if things are going to fall, right? And we have things that are going to fall down. When my apple falls and hits the ground, it's falling. Look at this. Now go back and visualize this, or put this back in your mind as a graph. We have our x-axis and our y-axis is falling down in a graph. That would be considered a negative direction. That's the reason why it's negative. Okay, in physics, for us to analyze things, we normally always put things into a graph form, okay? Into an x and y axis. It says here though, why is a gravity a negative direction or has a negative number? Not only that, it actually says a negative acceleration. Look at the SI units. That's an acceleration SI units. Not only is it an acceleration, but it's a negative acceleration. Not because it's slowing down. Okay, so negative accelerations do not always mean that it's slowing. It does mean that it's slowing down. It could mean that it's slowing down, but it also could mean because of direction. So because it's moving in a downward direction. Okay, because moving in a downward direction. Next part, what happens when the object is thrown upwards? Oh, what about that? Okay, that's not going to be until we have our class. I'm going to pause this video, come back, record some more, but there are some parts that I'm going to leave blank and open, and we will not see them, or we will discuss them, but not until we actually have class time. So I'm going to go ahead and highlight this for myself to know that this is where we do need to discuss, because this is an important part when it comes to learning your kinematics in 2 directions, okay?